Okay, this next video is parallel circuits. Parallel circuit is a circuit that has um, two or more paths for current to flow. Each path is called a branch. Okay, so right now we have one path. This is still, even though it looks weird from what we're used to, it's a series circuit right now. But when I add another path, now we've created a parallel circuit. There's two paths for current to flow. Okay. If I know my voltage and I know my individual resistors, I'm going to be able to figure out my amperage through the circuit. Okay. My total amperage here will be the sum of the amperage from each branch. Okay. So the formula we're going to use for a circuit that has two branches, we're going to use R1 times R2 over R1 plus R2. Okay. I'm not going to label these. I'm just going to say 2 times 2 over 2 plus 2 equals 4 over 4 divided equals 1 ohm. Sorry. Equals 1 ohm. So my total resistance is equal to 1 ohm. One rule that I want you guys to know is that total resistance in a parallel circuit will always be less than your smallest branch resistor or resistance. So here in this circuit, we're seeing this is 2 ohms, and this is 2 ohms. So my total resistance has to be less than 2 ohms. Okay, that's it. It could be 1, it could be 1.99. It'll be less mathematically. Okay, so now if I know my total resistance and my total voltage, I can divide them to figure out my total amperage, right? 12 amps. 12 volts over 1 ohm equals 12 amps. Okay, so I know my total amperage here. Okay, I still don't know how many amps are here or how many amps are here. But what I do know is that in a parallel circuit, the available voltage to each branch will be the same. So there's 12 volts here, and I also have 12 volts here. If I divide 12 volts by 2 ohms, I get 6 amps. And if I divide 12 volts by 2 ohms, I get 6 amps. Okay, so if I add my individual branch amperage, if I add this plus this, I get my total amperage. If I add another branch, okay, so if I add another branch, my amperage goes up. Okay, so if this was 2 ohms here, this would still get 12 volts, and this would become 6 amps. Okay, so my amperage goes up. So that means if my total amperage went up, what happened to my total resistance? Well, it must have gone down. Okay, so let's figure out total resistance. So now I'm going to get rid of this one because now we have a different formula to work with. So we know our total amperage is, okay, so we're going to use a different formula when we're trying to solve for total resistance when there is more than 2 branches. We're going to use 1 over R1 plus 1 over R2 plus 1 over R3, and it can continue, equals 1 over RT. So the first thing we're going to do is we're going to build our little equation. So 1 over 2 plus 1 over 2 plus 1 over 2. We're going to divide 1 by 2. We should get 0.5 plus 0.5 plus 0.5. That's going to equal 1.5. Then we're going to put our 1 because we have our 1 right here. 1 over 0.5, 1.5. So we're going to divide that, and we're going to get our total resistance of 0.66. I'm going to leave it right there. Okay, it's actually 666 and it continues, right? But I'll leave it right here. So that means my total resistance is 0.66. Okay, so if I know my total resistance is 0.66, I could double check my amperage because I can go 12 divided by 0.66 ohms. Okay, and when I do that, I get 12 divided by 0.66. I get 18 amps. Okay, which is the same as 6 plus 6 plus 6. So if I add branches, my total amperage goes up, my total resistance goes down. Okay. If I add resistance to an existing branch, okay, if I add resistance to an existing branch, what happens? Okay, so I'm going to add resistance to this branch right here. I'm gonna get rid of this guy here, and I'm gonna make this 2 resistors. Gonna be 2 ohms. Okay, so I added resistance. What happens to my amperage? Well, if I add resistance on this branch, it's gonna go down. Okay, so I treat this branch like a series circuit. I go 12 divided by 4 because I added these two. It's 3 amps. Okay, 3 amps. So I can add these 6, 7, 8, 9, and 12 and 3 is 15. Right? So I have 15 amps total amperage. Okay. I could figure out my total resistance 2 ways. I can go 12 volts divided by 15 amps equals 12 volts divided by 15 is 0.8. Okay. Or I could also use my 1 over R1 plus 1 over R2 plus 1 over R3. Okay. We're going to say that the R's symbolize branches. Okay. I'm not going to say resistors. So I'm going to call this guy R1, R2, and R3. Okay. So my first one is equal to 2. My second one is equal to 2. And my third one is equal to 2 plus 2 is 4. So then I'm going to write my formula like this. 1 over 2 plus 1 over 2 plus 1 over 4 equals. Okay, I'm going to divide them. 0.5 plus 0.5 plus 0.25 equals 1.25 over 1. And I'm going to divide 1 by 1.25. And I'm going to get 0.8 ohms, okay, which is the same as what we did here. This is solving a parallel circuit. Okay, it's a little bit longer, but I showed you guys the different things that can happen. Okay, let me know if you guys have any questions.